Okay, so this is question 2 for the 2024 AP Calc BC free response question. Um, question 2 is typically different from the BC question 2 is typically different from the AB one. So if you're looking for the AB, this is not it. Alright, this is calculator required, so let's jump into this. So a particle moving along a curve in the xy plane has position x of t, y of t at time t seconds, where x of t and y of t are measured in centimeters. It is known that x prime of t is equal to 8t minus t squared, and y prime of t is equal to negative t plus the square root of t to the 1.2 plus 20. At t equals 2 seconds, the particle is at the point 3, 6. Okay, so we have ourselves a parametric equation, so hopefully you guys are thinking to yourselves all those formulas that you use for parametric equations. Find the speed of the particle at t equals 2 seconds. Show the setup for your calculations. So speed. Speed is going to be equivalent to the square root of x prime of t. We'll say this x prime of 2, and then you're going to want to square that, plus y prime of 2 squared. That will give you your speed. Honestly, if you have this written down, that should at least give you 1 point. Most of the time they like to give you a point for having the expression given, and it's better to write it in general terms rather than with your specific equation, just in case you accidentally copy these down into your formula incorrectly. So if you have this expression, then that's a good thing. And then you can just use your calculator, honestly, for the rest. Okay, so I'll keep this here, or well, hopefully I don't mess this up, but we'll do the square root. We're going to do 8 times by 2, and then minus 2 squared. All that is going to be squared. Plus, then we're going to have negative 2 plus the square root of 2 raised to the 1.2 plus 20. All that's going to be squared. Okay, so I'm going to run this into my calculator. If you want to see me do that, I'll do that here. Okay, so let me go ahead and just do this. I'm going to do it step by step rather than just trying to put this all in one go. So I'm going to I'm also going to use this trick. So to store as my variable, to store as x, okay? And so now I just have to type in the equation. So our x prime of t was 8x minus x squared, okay? Enter. Okay, that's an easy one. So I'm going to square that, and I get 144. Okay, then I'm going to do negative x plus, I'll do the square root of x raised to the 1.2 plus 20. Don't forget the 2 if that will let me. 20. Okay, let me just double check and make sure I have this right. So negative x plus the square root of k. And I'm going to square that. And then I'm going to add the 144. And then I'm going to take the square root of that. And I got 12.305. 12.305 as my speed. Show the setup for your calculations. Find the speed. I'm trying to see if it's asking for units, but so centimeters and t is in seconds. So we got centimeters per second. That is my speed. Okay, and I have all my setup for my calculations, and there we go. Part B. So find the total distance traveled by the particle over the time interval from 0 to 2. Show the setup for your calculations. So distance traveled. That's going to be equivalent to the integral from 0 to 2 of our expression of speed essentially. So the square root of x prime of t squared plus y prime of t squared dt. And if you have this written down, I'm pretty sure you'd get a point. It's really helpful just to know your expressions and your formulas for parametric. It really comes in handy if you have them memorized. You'll get points just for writing this expression down as long as you specify your interval as well. Um, okay, and then I'm just gonna punch this into a calculator. Okay, I'll show you what I like to do. If anyone's interested. So what I like to do right here, I'm gonna plug in my formula for x prime. So x prime minus x squared, and then negative x plus we got the square root of x raised to the 1.2 plus 20. Just making sure that I have it typed in correctly. Okay, so now that I have those stored in there, um, I'm going to go to math. I'm going to do option number 9. That's going to give me my integral from 0 to 2. And then here, don't forget your square root. A lot of times students forget that. A lot of the times I forget that. And then I'm going to go to my variable button, go to my functions, y1. I am going to square that. And then I'm going to, oh man, see if it will allow me to, yep, there we go, plus, go back to here, and then go to my next one that I have stored in there. I'm going to square that one, and I hope this works. I don't know why it's overlapping like that, but hopefully that's just something with the software. Okay, so I have 15.902. So 15.902, and it's talking about distance traveled. And if I integrate this right here, remember that this x prime and y prime are the velocity. These are velocities of our x and our y. So if we integrate those, well, also again we're integrating speed, which would mean we'd just get distance out of that. So right. So centimeters is our unit of measurement there. So show the setup for your calculations. Find the total distance. Okay. Alright, I think that should be good. For part C, find the y-coordinate of the position of the particle at t equals 0. Show the setup for your calculations. So we're going to have to use our initial condition. So at t equals 2 seconds, the particle is at 3.6, and we're specifically interested in the y-coordinate. So if I want the y-coordinate at 0, so I want y of 0, right? So then that's going to be equal to, let's see, so I can do, before I do that, let me find the integral from 0 to 2 of y prime of t dt. So this will tell me the displacement from 0 to 2 of y. So the displacement in the y from 0 to 2. So let's find the displacement first. So good thing that I already have this in my calculator. This is another reason why I like to store these functions in here, so that if I have to ever do another calculation involving them, I don't have to re-enter it again. I'm just only time I had to put these in was once, and that was right when I put them in here. Okay, so my y is going to be y2. Just making sure I got that straight. Okay, so we'll go to math, option number 9. We're going to integrate from 0 to 2, and go back here. We're going to do this one right here, and we get 7.174. So this is equal to 7.174. So this is my displacement from 0 to 2, but keep in mind that I was at 6 right here when t is equal to 2. So if I was at 6 And if I go backwards, then I would want to say that this would be equal to 6 minus the integral from 0 to 2 of y prime of t dt, which is 6 minus 7.174. So I'll put that into my calculator. So 6 minus 7.174, and I have negative 1.174. So that would be my y coordinate at t equals 0. Okay, I think that should be enough. I'm okay with this right here. I'm saying that when t is equal to 0 for y, my y is this right here. That should be enough notation and to justify that. So okay. All right. D. So for from 2 to 8, the particle remains in the first quadrant. So just kind of illustrate this right here. So given whatever this particle is doing, it's saying that when t is equal to from 2 to 8, our particle is moving around in this quadrant right here. This is not its path. This is not the positioning of our particle, but it's definitely in the first quadrant whenever time is between 2 and 8 seconds. The particle remains in the first. For all times, find all times t in the interval from 2 to 8 when the particle is moving towards the x-axis. Okay, so essentially, since the particle is here, we're trying to find any time that the particle was moving towards the x-axis as t is increasing from 2 to 8 seconds. So, in any case, we're basically trying to understand when the particle is moving towards the x-axis, right? So that would mean that the velocity the velocity of y right here. So that would mean that y prime of t is negative. So when y prime is negative, that's when our particle will be moving towards the x-axis. Okay, so I think the only thing we need to do is we can graph y prime of t, so we can graph this right here, and then just see when it's below the x-axis. Only over this interval right here, though, only from 2 to 8. So going in here, I don't need this function right here. Let me adjust my window. So my x minimum would be 2, and then my x maximum would be 8. Let's see if that's good enough from there. Yeah, I think that should be okay. I mean, if I want to include the entirety of it, so I would just say, maybe if I go down here, do negative 3 to 3. Okay. Well, okay, so I just want to know when the function, when y prime of t is going to be below the x-axis, so I just want to look for where that intersection is. So second trace or calculations, we'll go to the 0, move our cursor left bound, click enter, move our cursor right bound, click enter, and then if it asks for a guess, just click enter again. But 5, 2, 2, 1, it seems like. So when x is equal to 5, 2, 2, 1, and to the right of that. So, so we'll say this right here. So so we know that y prime of t is less than 0 when t is greater than 5.221. Maybe we should put this in the interval. So we'll say 5.221 is less than t is less than 8. So on this interval right here, so find all times in the interval from, I guess I'll include this right here. So because it is saying included here. So find all times t in the interval from 2 to 8 when the particle is moving towards the x-axis. Again, that's going to be when y prime is negative, and y prime is negative when t is between 5.221 seconds and 8 seconds. I believe this should be enough for my reasoning. I think that should be enough for my reasoning, and that's my answer. Okay, I guess we'll see when the solutions are released. But okay, that should be question 2.